Welcome to section 1.2. Before you watch this video, you should try to answer all the questions in the preview activity on your own. So if you haven't done that already, please pause the video now and answer all those questions and then come back. Okay, let's see if we can answer these questions in our preview activity. They are all about the function g of x that's given in terms of the graph over here on the right. And that's all we know about this function. So, part A, what's the value of g of x when x is equal to 0? This is another way of asking for g of 0. So, what is the output of our function when the input is 0? Let's look at the graph. When the input is 0, there are two things happening in our graph. We have this black dot at vertical value 1, and then we have this white dot or open dot up at vertical value 4. Now the closed dot versus the open dot tells us which of those two values actually gives us our function value. So in our case, the closed dot, the value 1, tells us the value of the function. So g of 0 is 1. The open dot over here, you can think of that as explicitly having been taken away from the graph. So that is a missing value right there. We don't want that to be part of the graph. So this is what's happening at x equals 0. Part B is asking us what is happening to g of x as x approaches 0 but is not equal to 0. So they are asking what happens if we take x values a little bit smaller than 0 but approaching 0, or a little bit bigger than 0 or approaching 0 but approaching 0. What happens to the function values in this case? If we go up to the graph for values slightly less than 0, we are on this left side of the graph, and as x gets closer and closer to 0, the function values seem to be approaching the value 4. And the same is happening from the right. If we are taking x values slightly bigger than 0 and approaching 0, we are on the right side of the graph, and we are also approaching the value 4. So it looks like g of x appears to be approaching the value 4 as x gets closer and closer to 0. In part C, we are looking at the question is, what is the value of g of x when x is equal to 2? Let me clean up a little bit so that we can concentrate just on that part of the graph. So now we are looking at x equals 2 over here. And the question is, what's the value of g of x when x is equal to 2? So they're asking for g of 2. And our graph only has, it has a hole. We don't have an output value for input value 2 because, again, the open dot means that value has been taken away from the graph. So g of 2, we can't find an answer. The best we can say is it does not exist. Or another way of saying that is to say that g of 2 is undefined. Because there simply is no output value associated with input value 2. But what happens to g of x as x approaches but is not equal to 2? So again, what happens to the output values if our input values approach 2, either from the left or from the right? And something very similar is happening that we saw in part B. If we approach from the left, output values are getting closer and closer to 1, and if we approach from the right, also output values are getting closer and closer to 1. So we can actually say that the value that g of x appears to be approaching as x approaches 2 is equal to 1. So this is what's happening to our function values. Now part E is looking at yet another x value, x equal to 1. So let's clean that up. and look at what happens around x equals 1. So x equals 1 is over here. What is g of 1? That's part E. What is the value of g of x when x is equal to 1? That's another way of asking for g of 1. There are again two things happening here. We have a closed dot and an open dot. And the closed dot tells us what the function value is when x is equal to 1. So we get g of 1 is equal to 3. Next, again, we want to know what happens to the function values as we are approaching 1 but not hitting 1, because we already answered that question. We just want to know what happens if we're getting close to 1. They actually are asking us two questions. One, what's happening? And then the second part of the question is, do the output values of g of x that g of x approaches, does it approach one single value? Okay, let's see. So if we are going from the left, we are on the left side of our graph, and we seem to be approaching value 3. So for values less than x equal to 1, we are approaching 3. And for values greater than 1, let's go back to the graph, we are over here on the right side of the graph, on that right branch, and as x approaches 1, we are getting closer and closer to 2. So for values greater than x equals 1, we are approaching 2. The second part of the question was, do we approach a single value? And here the answer is no. 3 is not equal to 2, and we were approaching 3 as x approached 1 from the left, and we approached 2 as x approached 1 from the right. That is not a single value. So we saw a few different things that can happen to our function here as we were approaching a value but not really hitting it. So we are going to introduce some notation for what's happening here. So we're going to look at B, D, and F, at these weird questions that asked us what is happening to the values of g of x as x approaches a number but is not actually equal to that number. These questions that we are asking for, we have a term for this, and the new term, our new definition is we are calling these limits. So in part B, we were computing the limit as x approached 0 of our function g of x. So we call this a limit, and we found that the limit as x approaches 0 of g of x is equal to 4. We say this is the limit of g of x as x approaches 0. This is how we read this expression. In part D, we did something very similar. We computed the limit as x approaches, 2 of g of x. So I actually said it slightly different. The limit as x approaches 2 of g of x. And we found that to be equal to 1. And then for part F, we computed the limit as x approaches 1 of g of x. And that was 3 or 2. Well, is it 3 or is it 2? Well, if we can't find one specific answer, then we say that the limit does not exist. So in this case, the limit does not exist. At the bottom of the page, we have a definition. So let's just read that together. So we say that the limit as x approaches a of f of x is equal to L, which reads the limit as x approaches a of f of x equals L, if we can make f of x arbitrarily close to L by taking x values sufficiently close to a but not equal to a. So when we are computing these limits, we don't care what happens at exactly one point. We only care what happens to the function values as x approaches a value. So in our 3 example, x was approaching 0, 2, or 1, and we wanted to know what happens to the function values. And there were, 3 different things that happened. We're going to look at more examples and trying to get comfortable with this new notation and this new idea in the next few videos.